Okay, number 4. The motorcycle is accelerating, yeah? So what's your answer? I cannot hear you. Oh, it's so soft.
C.
C. Hamzah?
C.
C. Okay, correct. C is the answer. Now, if they said the motorcycle was moving at a constant velocity, what would the answer be?
D.
D. Betul. Okay, number 5. Which block is moving with acceleration? Ah, so easy.
C.
Yes. Number 6. The total downwards force for pushing a trolley is... I cannot really see. Let me just make it bigger for you. There's an F, there's an mg, there's an fy. Okay, let me just highlight now. There's an fx here. Oh, cannot see if I highlight. There's an fx, there's an fy, there's an mg, and there's an f.
C.
Downwards force. Yes, fy plus mg. Yeah? You look at the downwards, you only have fy and mg. So the answer is C. And number 7. You're going to try out number 7 before I show you how to do it. Let me know if you got the answer. I think you can use G is 10 or tak apa lah. I'm not sure if you will get, or if you use 9.81, you may get something close to it. But all answers are very close. Oops.
Is it D?
D. No, according to the answer, it's not D. I haven't calculated yet though. Hafiza, what you got?
I'm not sure. Is it B? Is it? I don't know.
Answer is B.
Wait,
But I'm
let me
not sure if the
cancel.
answer is
Oh,
right.
really?
Answer is B, but I'm not sure if the answer is right because I think I will use 10 first. So this,
Yeah, I'm deciding should I use 10 or like 9. So I'm not really sure about that.
now M is 2,400. So here's 2400. Now if I use 10, then it's just 24,000 newtons. Now they said that the car is sliding down a hill. Calculate the acceleration of the car. The frictional force is 400. So upwards here is 400 newtons. It's going down the hill. So I need, I cannot see this arrow. Okay, I need to find this force. So it's going to be 24,000. Cos or sine? Sine 30,
Sine.
right?
Yeah.
Okay. So 24,000 sine 30 minus 400 equals to MA. 2,400 A. So this is sine 30 divided by 2 is 12,000 minus 400 equals to 24,000 A. So what is A? The answer is 4.83. Answer is A. Okay, maybe they use 9.81. Wait, let me just double check. In 2,400 times 9.81 sine 30. Yeah, 2,400 9.81 times sine 30 tolak 400 divide 2,400. Ish, the answer is A, but the thing here put B wrong. Or am I looking at the wrong one? This is 1 point. Oh, I don't know which one is this. 1.3, correct. 1.3, the paper says answer is B. No, I don't think the answer is B. Answer looks wrong. Because even I use this method, sliding down the hill, calculate the acceleration of the car if the frictional force is 400 newtons, inclination is, definitely it's sorry, I drew this wrongly. Supposed to draw it this direction down. 2,400 times either 9.81 or 10. Yeah, but it's still correct that way. So 2,400 times 9.81 sine 30. I get my answer as 4.8 something, like even if you use 10 or so. So the answer is wrong. 4.8 something. Answer is A. So whether you use 10 or you use 9.81, you will get A. All right. So 5 is wrong, yeah? Okay or not?
Okay.
So you have to make sure you resolve the vectors properly. Okay. Last but not least, this is what we did last week, yeah? Springs. Now, which graph here represents Hooke's law?
D.
What is it?
E.
D, yes. D, Hooke's law. Yes, they didn't mention what happens after the elastic limit has been achieved. After the elastic limit, they didn't ask for that. So just a straight line for Hooke's law. Number 2. Which of the following method is used to identify spring constant? Is it the gradient of force extension or gradient of extension against force? Or the area under the graph of force extension or area under the graph of extension force? Which one? Spring constant is K.
Is it C?
Area under the graph
I
is
don't know.
not spring constant. Area under the graph is
Z N
energy. Okay.
Oh,
Gradient,
okay.
yes, A. So gradient will give me, so you have an fx graph. Okay, the gradient M is the K. The area under the graph A is the energy. Okay? Okay now. Faham ya?
Okay.
Now, number 3. 30 newtons is needed to make an extension of 18 to 20. So basically the extension here is 2 cm. So 2 cm is from 30 newtons. Now, what is the force that's going to allow it to stretch to 22 cm? Stretch the spring to 22 cm. First thing you need to find is what is the extension. You can use ratio or you can use F equals to Kx also to find. Up to you. Just want to check if I'm recording or not. Oh, yes. So what is the extension if the spring is going to stretch to 22 cm?
4 cm
22 minus 18, right? 4 cm. 30 newtons is required to stretch it 2 cm. But there's no answer here. According to it, the answer is B. 18 cm to 20 cm is 30 newtons. So F is 30. K don't know, X is 2 cm. So K is 15 newtons per cm. Now you have F equals to 15x. Now F we don't know, 15, X is 4. So it should be 60 newtons. So answer is 60 newtons. Tak ada jawapan. No answer. Okay. Number 4. You try number 4 first. Oh, grandpa's here. Okay, you all try first. I'm gonna give my dad a food, yeah? So you try number 4 first, and I'll come back. All right. So, what is your answer? Did you get the answer or not? Arif, Hafizah,
I'm not sure, but is it B?
you got B. Arif,
I'm not done.
you're not done. Okay, we give Arif some more time. Arif, still
I
doing?
don't know.
Actually, I still don't know what's the answer. Wait, let me check. Hafizah, I said what tadi? You
Is
said B.
it B? Like, I'm not sure.
The answer said is B. Okay, wait, let me calculate. I don't trust the answer scheme. So let me try, let me calculate. No, original is 15. So here is 15. So extension here is 5, right? So 60 newtons will give a 5 cm extension, but shared. So that means, this actually means 60 newtons originally will give me an extension of 10 cm. Okay? Because it's shared, it's 5 cm. So originally, if it's one spring, 60 Newton will give me 10 cm. Oh, correct. So here is 15 cm, right? So the extension is 10 cm kan? So the weight is 60 newtons. Betul, Hafizah? Arif, faham tak?
Yeah,
Can
I thought it was like you had to divide 5/2.
Oh, no. It's times 2. Okay, this is already, whether I can make it small enough for you to read or not. So you have spring X and spring Y. The relationship between spring X and Y when stretched by different forces. I have a feeling that the diagram is wrong, but tak apa. Which of the following comparison between X and Y is true?
So can you scroll up?
Can. It's just like this is nothing much actually.
Oh,
It's just a
that's never
diagram. It
mind.
doesn't make a difference actually. What they're asking comes from the graph. So which is the answer? To know which spring is harder, you look at the gradient. Okay, for an fx graph, the bigger the gradient, the harder the spring. So which is harder, X or Y?
X.
Yes, so answer is
A.
A. Yep. Okay, number 6. Hafiza, take some vitamin C to get better.
I did,
You did,
but okay.
I think you're just
Yeah.
exhausted lah.
Yeah, I think so too. I'm
Yeah.
still jet lagged anyway.
Yes, when you're jet lagged, you will be exhausted. Did you check for COVID or not?
I tested thrice and it's negative.
Negative, then okay lah.
Yeah.
When I traveled the last time, after the flight, I think I was the only one who kena tau. My kids all tak kena. But I was only positive for like 2 or 3 days. 2 days or 3 days. Okay, so which one shows the comparison between the extension of spring P, Q, and R? So which do you think is going to be the largest extension?
U.
Yes, U is definitely the largest. So we go based on elimination. So U is largest, U is largest. So it's either A or D.
It's D.
Your answer
Is
is
it?
D. How about
Huh?
Arif? Arif, no, I just want to know who's your Arif's answer first. Arif.
B as well.
D. Yeah, the answer is D. So you know the smallest extension will be T. So D is the answer. Number 7. Same material and identical length. So all of it's made out of same material and same length. Only difference is that you can see is the diameter of the spring, which is different. So we did this last week. There are few things that will affect the strength. Sorry, how strong the spring is. What are the few things that will affect the strength of a spring or the K of a spring? Length of spring, right? First one. Second one, diameter of thickness. Diameter of the coil. Thickness of spring. Diameter of the coil is the third one. Diameter of coil. Okay, from here, I can't see the difference. Is it the thickness which is lain? Oh,
Yeah.
diameter. Diameter tu the diameter dia saja. Ialah thickness lah kan? Diameter of the spring P and R are the same. Ah, okay. So P and R are same diameter, different thickness. Q is larger diameter of the coil. So we're not looking at material. So the fourth one is the material of the spring. Okay, so now based on that, which do you think is the strongest?
R.
You think R is the strongest? Or okay, strong. Stiffest lah. The right word is stiffest. Okay, so if R means, that means this is right, this is right. So it's either B or D. Now, which is the least stiff?
U.
Q. So answer is B. All right. Okay, now. I'm assuming it's okay lah. Number 8. Come, you try first. Number 8. Just show you the English part, yeah. Then you let me know what's the answer.
Teacher, is it B?
You got B. Okay, Arif, what's your answer?
B.
B also. Yes, the answer is B. Okay, so I don't need to explain since you know how to do. Number 9. The drawing looks a bit weird though.
Let's see.
You got C. Hafiza?
C.
Yep. Okay. Half fx. Although the drawing looks a bit cacat, eh? Number 10.
Let's see.
Hafiza, did you get C?
I got C.
Okay, good. Yeah, it is C, yeah? Half fx, yeah? Okay, now the next one I wanted to try actually is do a question like this. Like a exam type of a question. Okay, like this, shows a baby sleeping in a cradle. The characteristics of 3 different types of spring, KLM. Now it's a baby, yeah? Now they're saying that they want appropriate characteristic of the spring to produce a swing that can swing at the appropriate frequency. Don't know what frequency they want to swing it at. Okay, so so we're going to pick based on the spring constant, density, and elastic limit. So would you want a high spring constant or low spring constant?
High.
High. Okay, so you put here high. Now you must give a reason why. You must
Does
give
it differ?
Okay, you can say it's stiffer. Okay, stiffer. You can also mention able to withstand a larger force. Huh? A larger force. Okay, density of the spring. Would you want it to be low density or high density? So we've gone for high. So you either have low density or high density.
High.
You want high density. Hafiza? Low or high?
I don't know because honestly, like, why?
Yeah,
I
that's
don't
why
know.
you must know
What's
why.
yeah?
Low
I
density.
don't know.
Why low density?
What's the function of the density?
Why low density? When something is low density, it is lightweight. Okay, and
Oh,
so when
okay.
it's lightweight, it is portable. You know what's portable?
Yeah.
Easier to,
Bring around.
I
Yeah.
guess.
Yeah. Okay, so it's lightweight. So I know this is a low density. So my elastic limit is larger or high. Higher ke, high ke, or large. Now, why do we want a high or large elastic limit?
To make sure they don't get damaged easily, or I don't know how to make a
Okay.
sentence for that.
Now, this kind of questions, actually, once you've done many questions, you will know how to answer. So you can say can withstand high force, also can. You can say lasts longer, pun boleh. You can also say does not break easily. So there are many explanation to this. Huh? Okay, now. So once you have done many questions, you will know how to answer questions like this in bahagian B. Yeah? So most appropriate spring is M. So you must understand what the question is asking. If you pick the wrong things, then you will not get your marks. Huh? Now this last one is a part C question, which I want you to try. Yes, this one. It's also suggestion and reasons with the aspects. Like whether you want large diameter, small diameter, tire width, material, thread pattern. Okay, now this one, they give you everything. Huh? So now they're saying, employee carrying a gas tank, motorcycles modified to patrol the beach. You're going to patrol the beach. Using appropriate physics concepts suggest and extreme modifications that can be done. So your answers should include all of this. So I give you some time to think. I think diameter of spring you can see from your notes. Material for seat and all, actually you can use common sense. Huh? I'll give you a few minutes to think. Oops, I don't know what I'm pressing here. Oh, okay.
Teacher,
Yeah.
when they ask for material, do you have to be specific or you just say
No,
like
it
the
can be something like
characteristic?
yes, characteristic pun boleh of the
Okay.
material, not necessarily type of material. No, don't have to be that specific unless they say no, list the type of material or what. If not, no. You can be specific if you know what material you want, but if you're not specific, you can just tell the characteristic of the material. Okay, what I'm going to do is I'm going to restart.